This is the Orwell computer. I thought the best way to show the new graphics capabilities it's got would be with a little film. It's actually quite hard to film it because it's hard to film the screen, but we'll see what we can come up with. This is the actual computer itself. So it's all just built on VeriBoard. Underneath there's a whole bunch of wires linking it all together. The keyboard's from an old 80s Texas Instruments computer, which I just got off eBay. And this is the new little video module, which is based off a design by a guy called Grant Searle, who's on the internet. And he's got all the source code and the hardware there to show how to build one of these. That gives me 80 column black and white text, and it also gives me 160 by 100 pixel resolution graphics. So it's very simple graphics, but that kind of keeps with the style of this computer, because this is supposed to be an 80s style computer. It's running basically a custom version of the original Microsoft Basic, which is from about 1977, 1978. I started with the OSI version because that's the simplest version, and I've been adding to it ever since. There's a few tricks and a few quirks to it that you have to learn, but once you get it going, it actually works pretty well. The machine itself is 6502 based. I get most of the chips out of old Commodore 64 floppy drives. There's 16K of RAM. I'm actually using a 32K RAM chip, but I only access the first 16K. And there's 32K of EEPROM, which is this here. So anytime I make changes to the actual system, it all gets burned onto the ROM and then run from here. I'm running a 6522 VIA chip, which is controlling the keyboard and also talking to the video board. And I'm running a ACIA chip to do serial communication. That's basically what the netbook's here for. Is I have that hooked up to the serial port, and my load and save routines actually read and write to the serial port. So I'm sort of cheating there and using it like a sort of pretend floppy drive or disk drive, or tape drive would be more appropriate. So we can sort of see the screen if we turn this on and reset it. It basically comes up with the original Microsoft Basic boot stuff. So it's actually asking if we want to cold or warm start, so we cold start it. It prompts you for the memory size and the terminal width, and then it's basically up and running. Now, the easiest way for me to show this is to basically send it some of the little programs I was writing to test the graphics. So what we can do is we can say load. I've also actually got what I call echo load, where it goes into a loading mode and then I can send it programs from the netbook. It's basically being sent over the serial port. It's quite slow. I actually have a glitch somewhere in my serial routines, and so it's not fully reliable if I try to run it too fast. So at the moment I have the speed set fairly low. So we can get rid of that. Of course you can list. This program sort of demonstrates some of the graphics capabilities, but we'll start with something simpler. I also have the silent load function, which doesn't echo to the screen basically. So we can send it another file. To get out of the loading mode, you just hit Control-C, and that should have loaded a new program, quite a small program. All this one does is it should just draw random rectangles. So if we run that, basically that's all that one does. My graphics routines are very simple. Plotting a point is easy enough. It turns out drawing a line isn't as simple as you would think. If you're drawing lines at 90 degrees or 45 degrees, it's quite simple. But if you're trying to draw lines at any angle, there's a special algorithm you can use that works it out for you. That's the line drawing. the way the graphics processor works, if you're trying to print characters on the same line as graphics, it goes a bit strange. It doesn't really support that, but we can clear the screen and start again. So that's basically drawing rectangles. If we say new and load, we can load another program. Now, the next thing I did was drawing circles. Once I had lines and rectangles and so on working. Circles are also a bit tricky. There's a little algorithm you use to work out how to draw the circle. The interesting thing is, of course, once you've got drawing lines, you can actually draw circles in BASIC using this algorithm. I actually came across two algorithms. One is a simplified version, which was actually in a Commodore hacking magazine from about 1995. This should be the basic interpretation of that. Now, when you draw a circle, you basically work out an eighth of the circle mathematically, and then you draw it effectively mirroring it. So it simplifies it a bit, which is why you've got all those sort of plot statements there. It's basically plotting the 8 different quadrants of the circle. So if we run this, we can give it a radius, X center. We'll just center it on the middle of the screen, and it draws a circle. And that's using BASIC, so that's quite slow. So what I did is I wrote assembly language routines to draw the circles for me, which is much quicker. So if we load that, we just find our assembly language routine. So basically, all I'm doing when I'm loading these things is using a terminal program on the netbook, spitting the characters out down the serial port. And then on here, we just Control C to get out of the mode. We can list it, just make sure it looks correct. And then if we run this, so this is just drawing random circles, same as I was drawing random rectangles. And that's just using the assembly language circle drawing routine, which as you can see is much quicker. I mean, it's not blindingly fast, but for a machine of this nature, that's perfectly acceptable. I'm quite pleased with how that works. So we can quit out of that. New. And we can go back to... This is the little program I wrote just to test the circles and the rectangles and various other things. So we load this one, it's a little bit bigger. Check that we've got it. That looks okay. Now, if we run this one, basically it's just drawing random circles and rectangles on the screen. But it is also, I'm using the radius because it's a good random 8-bit number, and just displaying it on the little LED display here. And also using that radius to drive the sound. And the sound is just driven off the one of the pins on the wire, which actually has a hardware-driven timer. And basically, I'm just setting the timer, and all that does is it runs for a certain amount of time and then interrupts. I'm not actually using the interrupt. I'm just driving directly off the hardware pin, and I just have the little buzzer attached to the pin. So you send it a value, and it just automatically in hardware sits there and triggers that pin every so often, and that's how I'm producing the sounds. And so all this program does is kind of fills up the screen. It gets to a certain point and it just reverses the colour and starts filling it up in black, so it kind of draws the screen and then clears the screen and sits there and makes silly noises and flashes lights. And this will run for as long as I keep it running, basically. But the graphics are fairly quick. I mean, It's not blindingly fast, but for this machine I think that's pretty good. Basics running pretty well now. I keep adding commands. I did have a snag where I'd added too many commands and I had to start modifying some of the code to allow me to look up tables greater than 256 bytes. But that's done now. That seems to be working. I need to tweak my serial routines, as I was saying, and there's some sort of bug there, I think to do with the CTS RTS flow control. I think it can get into a state where it locks up the machine. So that's something to look at. And other than that, I will just keep reviewing my Asciimation books, of which I now think I have a full collection of the 80s books. So I'll keep adding those to my website.